Well, hello there, wonderful young people. Let's use this TI-30 series in the Dixon Ticonderoga number 2 to do this paper 4 question. Actually, when you take the real one, you got to use a pen, except for diagrams, stuff like that. But we're going to use a pencil for our purposes here. All right, so let's get to it, right? We got some trigonometry going on in here, I would imagine. It says calculate the area of triangle BAC. So that's this triangle right here. That is not a right triangle, as far as we know, but could be. The formula for the area is going to be 1/2 sine of angle A uh, times BC, I think. Let's check. Let's go back to the front page. It gives us all our reference sheet right here. We're fortunate. The United States gives you, like the Cambridge test in the U.S. gives you the formulas. Yep, 1/2 BC sine of A. So 1/2 sine A BC. Right. 1/2 BC sine of A. So here's the deal. Um, side B and C. They don't really matter what you call side B and C. Here's the difference, though. Here's the thing. Whatever you call angle B, like say this is angle B, this would be side B. It's opposite, you see? So this is the angle we know. That's A. So this is going to be side A right here. You follow me? That's side A because that's angle A. So here's what we've got. We've got area equals 1/2. Let's see, 15 times 19. 15 times 19, those are the two sides, and the included angle, sine of 40, that's not one we have memorized, so let's do this, shall we? So zero point 0.5 times 15 times 19 times the sine of 40 degrees, 9, so that's going to be 91.6. So that's three significant figures. Um, that's good. Three significant figures is what we're supposed to have. Let's make sure our units are there. That's good. Centimeters squared. That's good. If it wasn't there, we'd have to write it because sometimes they'll take a point off if you don't have your unit, but the unit's already posted, so we're good. Calculate the length of BC. That's this side right here. Oh man. All right. So calculate the side of BC. Well, we got a couple options. We got the law of sines, and then we got the law of cosines, or sine rule, cosine rule, however you want to say it, right? Here, uh, well, we know that the opposite angle is 40. We have two sides, so we have two sides in the angle, so we're going to have to use the cosine rule, right? So let's make sure. Let's start off with our formula right here. It's been a while, so here's the cosine rule: a squared equals b squared plus c squared. I think it's, what is it, 2 bc sine a, something like that. Let's double check. It's been a few months. Yep, 2 minus 2 bc sine of cosine of a. 2 times b times c times the cosine of a. So that's our formula. So always write out your formula. It's worth 3 points to get this right. So a is going to be this side right here. That's going to be the square root of the whole thing, right? So a, which is, it's really, in our case, it's the length BC. It's going to be 19 squared plus 15 squared minus 2 times 19 times 15 times the cosine of 40 degrees, 40 degrees. So write it all out, be very, very careful, and then you have to use your calculator very, very carefully not to mess this up, okay? So calculators, they don't do order of operations very well. They kind of do it exactly as you type it, not as it should be. So let's see. Let me arrange this so we can see the calculator and the paper. All right, here we go. Let's go ahead and clear this. So I'm going to do the inside calculation first, and then I'm going to take the square root of that whole thing. And you can do that with, you see this right here, so above this it says ANS, so you get the second button and the answer. So we'll look, so 6 times 3, right, 18, right? So we could do 9 divided by 18. We know that's 1/2. Do you see? Did ANS, so 6 times 3 is 18, right? So I could do 9 divided by, and then second answer, and then it has that 18 in memory. So that's how that works, right? So 15 squared plus 19 squared. So 15 squared plus 19 squared. Got that. And then minus 2 times 19 times 15 times the cosine of 40 degrees. So that's 149.3 whatever, right? So I'm going to do that again just to make sure I got it right. So 19 squared plus 15 squared minus 2 times 19 times 15 times the cosine of 40 degrees Yep, same thing. Okay, now I'm keeping that in there, right? I'm not gonna write the whole thing out. I'm not gonna retype it. It's gonna stay there. So watch how we're gonna do this. I'm gonna do square root, so second and square root, and then second, and then the answer key right here, and you see, and then I'm gonna hit equals. 12.2 to correct to two significant figures. So BC is 12.2 centimeters. 12.2. Boom, done. Onward and upward. Angle ADC, ADC is obtuse. It's interesting. It says that calculate angle ADC. So we've got this angle right here. Let me write this down right here. This was 12.2. Okay, so this angle right here is obtuse. Well, I know this is 19. So like check this out. Here's what we got. We've got 19. We've got 11. We've got 35. And this is obtuse. So this one, it looks like we can use the law of sines, right? So we don't know this angle right here. We do know that angle. So the sine of 35 degrees divided by 11 is equal to the sine of x degrees, we'll call that x, right? Divided by 19. So if we go ahead and solve this whole thing right here, this is worth 4 points, okay? That obtuse is really interesting because I bet when we do this, we're going to get, I bet we're going to get an acute angle. So let's go ahead and do this right here. Let's go ahead and do this. We're going to multiply both sides by 19, and we have to take the arc sine. So check this out. Here's what we're going to get. We're going to get x equals, so you multiply both sides by 19, right? Multiply both sides by 19. So you're going to get the sine of something equals that. So arc sine of the whole thing, 19 times the sine of 35. Excuse me. It's not a COVID cough, I promise. Divided by 11. Okay, so once again, calculator, you got to be careful with these right here, right? So let's be careful not to make this make any mistakes here. So probably do it twice. So I'm going to do the inside calculation first, and then I'm going to take the arc sine. So 19 times the sine of 35 equals. That does the. I have to do the order of operations. So I'm doing the top first, divided by 11, and 0.99. Second, sine. That gives me arc sine of my answer. 82. So this says 82.2, which is an acute angle, right? That's an acute angle. 82.2 is an acute angle. Now, how do you get the obtuse angle from that, right? How do you get the obtuse angle from that is you're going to subtract it from 180. So you're going to get 180 minus that. So it's going to be 97.8. 97.8 degrees. Now here's why that works, right? So let me go ahead and explain this to you real quick. So if you think back to your unit circle, right? You got your unit circle. It's on a coordinate plane, right? You've got the origin right here. Sine is the output. It's y. Okay, it's how high the output is. So check this out. So let's take a look at this angle right here. Let's say this is our angle. This distance right here is sine. Do you see? Right there. There's another angle over here, like a circle will go around, right? It would be cleaner, I mean. There's another angle over here that goes all the way to there that will have the same exact sine value. And so they're going to add up to 180. They're going to be supplementary, so you're just going to subtract this from 180. So it's going to be 180 minus 82.2, and that's going to give you the obtuse angle. So anyway, man, got a lot of trig on there. That's a tricky question because of the concept at play. You got to be careful. Let's see if we make sure we're done with number 4. We are. Man, hope it's been helpful. You wonderful people have a great day, and I'll see you on the flippity flop. I know I got to say something weird every time, right? Have a good day.